Composite Functions, Chapter 5, Section 1. Composite function. Given two functions f and g, the composite function denoted by f with a little circle symbol in there times g, do not confuse that with the multiplication dot. It's read as f composed of g is defined by f composed of g of x is equal to f of g of x. Simply, it's saying, and I tend to read it as f of g of x always, it's just saying take the second function and substitute it in for x in the first function. So it's just a standard substitution, but it's the composition function or the composite function, f of g of x. The domain of f of g of x is the set of all real numbers x in the domain of g such that g of x is in the domain of f, meaning that g, since it's the function that's being put into f, you have to find the domain of g. But then also, since the output of g is going in as an input of f, you have to find the domain of f and then make sure that g never violates that. So you have to find out what values of x being put into g will cause it to output something that'll cause a problem for f. So that should be clear as mud. Well, how do we evaluate a composite function? Well, let's take a look. So we've got f of x is equal to x plus 2 over x plus 5, and g of x is equal to x minus 3. And we want to find f composed of g of x or f of g of x. So to do that, all we're going to do is we're going to take g of x, that x minus 3, and we're going to substitute it into f of x. So we've got f of g of x is equal to f of x minus 3 because g of x was x minus 3. So we just substitute x minus 3 anywhere there was an x in f of x, giving us x minus 3 plus 2 over x minus 3 plus 5. X minus 3 plus 2 gives you x minus 1. X minus 3 plus 5 gives you x plus 2. And that's how you do it. It's just substitution. We've done it before. This is no different than me saying, fine, and given the function f of x equal to x plus 2 over x plus 5, find f of x minus 3. It's just now, instead of saying of x minus 3, we say of g of x, where g of x is x minus 3. What about finding the domain of the composite function? So given two functions f and g, the domain of f of g of x is found by doing the following. First, find the domains of f of x and g of x. Then, set any restricted values of f of x to g of x and solve, meaning plot anything that is not in the domain of f of x, make g of x equal to that, and solve to find out what values or what inputs will cause that problem. And then 3, find the intersection of the domain of g of x and the solution found in step 2. So basically, obviously, any values that are not allowed for g of x can't be in the domain of this composed function, but also any values for g of x that will create a problem for f of x also cannot be in it. So let's take a look at this. If we've got f of x is equal to x plus 2 over x plus 5, and g of x is equal to x minus 3, and we just looked at that moments ago, that's where we got the composed function or composite function of f of g of x is equal to x minus 1 over x minus 2. We want to find the domain of f of g of x. So looking at f of x, we see that we cannot allow x to be equal to negative 5. Excuse me. And looking at g of x, we see that it can be any real number. So the domain of f of x is x not equal to 5, and the domain of g of x is all real numbers. So now I know that f of x can't have an input of -5. So I'm going to set -5 equal to g of x and solve to find out what value of x in g of x will cause us to get -5. So -5 is equal to x minus 3. So x equal to -2. So if we have x equal to -2 plugged into g of x, that's going to give us an output of -5, which is not a valid input for f of x. So we now are going to combine the domain of g of x, or I should say find the intersection of the domain of g of x and those values that will cause problems for f of x. So since g of x can have any real number as the input, then our only restriction is that we can't have x equal to -2 because that would cause a problem for f of x. So the domain of f of g of x is equal to x not equal to -2. Showing that two composite functions are equal. Given two functions f of x and g of x, the composite function f of g of x is equal to the composite function g of f of x if and only if f of g of x is equal to x and g of f of x is equal to x. Okay, so if those two are equivalent, then this is what's going to occur. Well, let's look at an example and see if the composite functions are equal. If we have the function f of x is equal to x squared minus 3, and g of x is equal to the square root of x plus 3, determine if f of g of x and g of f of x are equal. So first thing I'm going to do is I'm going to find f of g of x. So I'm going to essentially plug the square root of x plus 3 into the function f of x and see what I get. So f of g of x is equal to the square root of x plus 3, that quantity squared minus 3. So I just plug g of x in for f of x, which gives me x plus 3 minus 3, which gives me x. So far we're good. What about going the other direction? So now I'm going to take x squared minus 3, the f of x function, and plug it into g of x. So g of f of x is equal to the square root of x squared minus 3 plus 3 is equal to the square root of x squared is equal to x. Thus, f of g of x and g of f of x are equal. Finding the components of a composite function. Well, when you're finding the components of the composite function, you're really just looking to see what are two functions that if I plug one into the other one is going to give you this composite function. So we look at the fact that f of g of x literally means f of g of x. What function can I plug into what other function to give me this final function, h of x, that we have here? So I see that we've got 3 over x minus 5 squared. Well, what are some possible answers? Well, if I look at this, I could say, well, maybe the function f of x is 3 over x squared, in which case g of x would be x minus 5. So if I take f of g of x, I take x minus 5, plug it in for x in the function f of x, and I get x minus 5, the quantity squared, 3 over that, which is 3 over x minus 5 squared. But that's not the only possible answer. Another possible answer could be, well, what if I said the f of x is 3 over x? Then g of x could be x minus 5, the quantity squared. So realize that when you're finding the components of a composite function, there can be more than one way that it could work. But make sure that your way really does come out correct, because every now and then you see someone, they come out with a very interesting thought process, but not quite accurate. But do realize that just because your answer is different than somebody else's answer, that doesn't necessarily mean that one's wrong. You may have just seen that composite function in a different light.